Okay, I have just a couple minutes before I'm going to go eat lunch, but it's moving day and y'all want vector videos, so here comes the one on the scalar product. The scalar, we also call this the dot product because we write it with a dot. So the dot product, the scalar product, they mean the same thing. The scalar product of two vectors results in a scalar. Okay, so we have been able to add vectors before, we've been able to subtract vectors, but we can't say that we're going to multiply two vectors because there's actually two ways to multiply vectors. One of them is take the scalar product, and the other one is, well, I don't know where my other worksheet is. The vector product, okay? So the scalar product results in a scalar, and a shocker, the vector product results in a vector. So that'll be another video, we'll get there eventually. Okay, so what happens is if we want to take the scalar product, what we do is we multiply, then add them all together. So it becomes a1, b1 plus a2, b2 plus a3, b3. And that's the scalar product of those vectors a and b. So let's do one. So if I'm taking the dot product or the scalar product, those are used interchangeably, of a and b, I can say that a dot b is equal to, well, 4 minus 10 minus 6, which is equal to, what is that, negative 16 plus 4, negative 12. And so the dot product of these two vectors is equal to negative 12. Notice this is a scalar, and that's what we found when we did the dot product. Okay, so we're going to use this. The scalar product is really helpful, and I think I want these three to be in their own video. No, let me get started. We'll see how far I can go. Okay, so what we know here is this, they're asking us to go back to the law of cosine. And so this, if we look at, talk about the magnitude of each of these vectors, then we know that cosine of c, I lied, cosine of theta, is equal to the magnitude of a. Well, what do we do? So it was, the law of cosine was cosine c is equal to a squared plus b squared minus c squared all over 2ab. Okay, so over here, it's the magnitude of a squared plus the magnitude of b squared minus the magnitude of c squared, all divided by 2 times the magnitude of a times the magnitude of b. Okie dokie. So we want to find the magnitude of c in terms of this. Well, so first of all, what is vector c? If vector a, notice we need, vector c is going to be equal to negative a plus b. So vector c is going to be equal to, well, a negative a1, a2, a3 plus a b1, b2, b3. Okay, and so this is equal to b1 minus a1, b2 minus a2, and b3 minus a3. Okay, so they want us to find the magnitude of this in terms of these. So the magnitude is going to be each of these guys squared. Well, the magnitude of c is equal to the square root of b1 minus a1 squared plus b2 minus a2 squared plus b3 minus a3 squared. That's the magnitude of c. And so now they want us to solve for this in terms of vector a, vector b, magnitude of a, and magnitude of b. So they want us to get rid of this magnitude of c, and I think it's almost time for my lunch. So I am all about lunch. So I'm going to stop at this point and we'll come back, I promise.